All right. Hey everybody, how is it going? Hello, hello, Norland. Okay, so tonight the goal is to try a couple of different things on the stream. So in the last one, I used just straight up OBS to stream, and this time around I'm trying Streamlabs out just to see how that works. So just trying to get used to using all the tools and all that kind of stuff. So basically, I have a couple things in mind that I wanted to do tonight. I want to do a little bit of refactoring our code base. There's a couple things that I've called out in the previous stream as well as in some previous videos that really needs to be fixed because it doesn't really make a whole lot of sense. So we're going to go ahead and proceed with that. And then we're also going to add another feature tonight to the engine, which is going to be the Kvar system. So we're going to program that live here on the stream. So basically, it's primarily just going to be me walking through the design process, the thought process behind the reasons I'm doing all the things that I'm doing. And then if you guys have any questions along the way, feel free to chime in and ask. I'll be more than happy to answer them. Like I said before, this is a new streaming channel, so my YouTube channel, I'm used to having like a follower count of like 9,000, and on this one I have like 15. So it's going to take some time to grow it, but it should hopefully be growing here in a little bit. But anyways, with all that stuff out of the way, let's go ahead and jump into it. So the first thing that I wanted to kind of talk about was the application, because this is something that's come up a few times. And the application right now, where it actually sits and what it actually does, application doesn't really make sense for it. So basically, we have here in our description that the application is responsible for managing both the platform layers as well as all the systems within the engine. But right now, the application actually sits in the engine, which really doesn't make much sense. So what we're going to wind up doing instead is, instead of having it just sit in the engine itself, we are going to turn what we call the game right now into the application and turn the application into the game. So let me go ahead and swap my display here so that you guys can see what I am looking at. All right, and it looks like you guys should be able to see that, so we should be good to go on that. Okay, so I guess the first part of this is we're going to start by renaming the application to engine. So I'll go ahead and rename that here and here. I'll start with file renames first, and then we'll sort of work backwards from there. I'm also going to find all application H includes and change those to engine.h. And we'll replace all of those. Get rid of that. All right. And then we're going to have to change the actual types itself. So we have right now an application config, and application create, application run, and get frame buffer size, which, are we actually even using this anymore? I don't actually even know if we're using, we might be able to just get rid of that altogether. I don't think we're actually using this. So actually, this is deprecated, and it's just a getter. So if we're not using it, I am going to go ahead and get rid of it because we don't need that. So let's go ahead and rename this to, we'll call this engine run, and application create will be engine create. Let's see. So we want to include that. That is the K error. And we'll include entry.h because that also needs to I believe, be included. Yes, okay. So we'll go ahead and apply that. Change the comments so that they're accurate. Pointer to the game instance associated with the application. We're going to say associated with the engine, and we're going to call this the application instance. And I'm not going to rename this just yet, but I wanted to update the comment before I actually forget to. The main engine loop, and that should do it for this file. Wait, no, we need to do the config as well. So we'll have engine config. All right, I believe all of these variables can stay the same. So yeah, that should be, let's see. Maybe this should be at the application config still. Because technically speaking, the engine is being configured for an application. Yeah, I'm going to leave this named application config. That actually does make sense. I may want to move it to a different file though, but configuration for the application. The application config is fed to the engine on creation, so it knows how to configure itself internally. All right. So that is that. And the next thing that I'm going to do is just kind of quickly step through the engine, what is now the engine code, and change a few things. So what we do have here is the application state. This is no longer, oops, this is no longer valid. That should be engine state. And let's see. So engine state. We'll leave that rename alone for now. Okay, so that should be fine. Because this is actually the state of the engine. All of this stuff needs to also be moved to a systems manager, which we haven't done yet. I'm really wanting to do that soon though, because as you can see, this is kind of getting out of hand. So we probably will move that here shortly. I'm also going to rename app state to I guess I'm just going to call it, should I call it state? I think there's things that are actually called state locally. Let's call this can't call it engine state because that's the same thing as the struct is called. I mean, I suppose I could rename this to engine state T. And then I could call this engine state. That seems kind of dirty, but I think I'm going to roll with that for now. All right, so the next thing that we need to do is just kind of rename these functions in here to engine on event, engine on resized. So by the time this is all done, hopefully this will make a little bit more sense, because it was getting a little bit nebulous before in terms of when we were talking about the engine, when we were talking about the application. So I think all of this initialization code should be able to stay the same. We have our engine run here. I think all of this should be able to stay the same. This is the function that we nuked. I don't believe we actually need that anywhere. And that's all instances of that, so that can actually just go away. Let's just search for application within here. There's 20 I'll bet most of this is probably logging. And the word the game instance application state. So I guess we should probably rename that next. This is going to be the engine state, created and managed by the engine. So let's just rename this to engine state and go back. Still have a lot of instances of application. But I guess aborting application makes sense. So we'll leave those. I think this is mostly going to be logging. Application quit, that's fine. Suspending and resuming application. This should probably say engine state. Memory tag application. We should probably rename this memory tag too. Let me not do it here. I'll go over here and do it. So memory tag engine, which means we're also going to need to go into kmemory.c and adjust the array. So we have an application here. This is going to be engine. And okay, I think we've got everything here split out. So I'm going to go ahead and do a clean build. And like I said, along the way, if you guys have any questions about what I'm doing or anything in the series along the way, for those of you who have watched the series before this, please feel free to hit me up in chat and I'll answer your question to the best of my ability. All right, so we've built, just for good measure, I'm going to run a post build, just build our shaders real quick. Looks like that is all good to go. And let's run. And of course, because just Windows things, it has launched a different window. But it looks like we are loading up all of our test assets, and it looks like it's running as expected. So that's good. Speaking of which, there is one thing that I forgot to do. So we know our refactoring is good so far, but before I move too much further, I do recall that last time I had actually forgotten to commit the code from the last stream. So what I've done here is I've gone ahead and pushed up the branch, which I've renamed to feature console. Technically, it includes key maps and all that stuff too. So implementation of console consumers key maps / bindings and stack container. All right. And so this basically just includes all of the code that we did in the last stream that we went over. So there's no real need to step through any of that here. This is all stuff that we have put in before. So I did this as a pull request so that you guys can actually see the commit history within the repo. So I'll go ahead and create the pull request, and I will go ahead and override that and merge it. So I don't need all that. Confirm squash and merge. All right, and delete the branch. Cool. So main should now be up to date with the latest and greatest code from the last stream. And before we end this stream, I'll go ahead and do the same thing. Make sure to push the code as it should be. All right. Anyway, oh, that's right. This is another thing we have to fix is these Vulkan errors. I forgot to fix that in the last stream, so we'll fix that too. All right. So we have the engine refactored, or our old application is now engine. So I believe, let's see, let's just update these comments here. This file contains restrictions and logic containing, yeah, let's just get rid of the word application there. The engine responsible for, yeah, okay, all right, so that makes sense. Okay, so engine is done. The next thing that we need to address is we have this concept of game, which is our structure defined here. And so what this was originally meant to be was we would, if you recall back to our original discussion on the architecture, is we were considering the consumer of the engine library as a game, which is not wholly incorrect, but it's not inclusive of every potential for that. So what I mean is we have a couple of different consumers that we're going to wind up writing. So a game is one of them, but also an editor is another one. So the editor is going to be its own sort of standalone application, and then the game runtime will be separate as well. So both of those things are consumers of the engine, and so it doesn't really make sense to call the editor also a game. And so I'm going to rename this structure here to application. And this is going to wind up actually being what we really refer to as the application instead of that old structure that was in the engine that we were calling application that's now engine. So I know that's kind of confusing, but this is to eliminate that confusion. So application config, as you can see in this context, actually does make sense, which is why I chose not to rename that. But the game here, which contains all of the game data and callbacks and things like that, we're going to go ahead and rename this application. And I would not be surprised if we have some of these not being picked up correctly. So let's just step through all the changes here. Let's see. So we're going to rename that. That's good that it actually picked that up. Okay, I wasn't expecting that. That looks correct. Where is this? Okay. All right. I think this is actually looking pretty good. Yeah, we'll go ahead and include this one as well. Let's see. Some of these briefs might also need to be changed. Consumed by the game library, that should be application library. Represents the basic, this should probably say application state in a game. Actually, application state in an application. That's kind of weird, but whatever. Let's see. So, yeah, I think most of these things are fine, honestly. I'm just going to accept this as it is. And do a save all. Actually, it did save everything. Okay. This should be application boot sequence. In fact, let's do this. So instead of game instance, this should be, we'll call this app inst. Oh wow, it didn't pick it up here. Okay, that's kind of annoying. Let's app inst. I'm gonna have to do all these manually, aren't I? I'm not too surprised. These function pointers get a little bit weird sometimes about this. Just a few more. think this is the last one. All right. Game frame data. That's another thing that we need to rename, actually. So this should probably be app frame data is what we're going to call that. All right, so if we start here, we will accept that one, accept that one, that one, that one, that one, that one. Probably all of these. Application specific app state. That doesn't really make a whole lot of sense. Okay. Kohi game engine, that's the only one I'm going to keep here. And that's game types .h, which I suppose probably ought to be renamed too. So this should be application types, which is going to break some includes, most likely in the game itself, but let's see. I'm going to guess here, yeah. Application types. Let's go ahead and let's do a clean and rebuild on this real quick. So chat, how are you guys doing tonight? Hope everybody's doing well. Looks like we got some errors. That's probably, yeah, that's game types. That should be application types. Okay, let's build that. Missed another one, entry.h. Should be application. Okay. Why are you IntelliSense? Let's just reload the window, I guess. All right. So this is probably another place where we're going to need to change out some naming. So we have this create game, which really should be create application. Yeah, we want to include that one as well. Okay, so apply that. Application. All right, and we're going to call this out app. Change that and change that. Apply that. Okay. All right, so I think I can literally just go through here and so application, we have game inst, that should be app inst. All right, engine loop. Okay. Request the game instance from the application. Yeah, that doesn't make any sense. Okay, so this should be the application instance from the application. Yes, because the application is responsible for creating itself. Okay. Let's see, what else in here is called game? So this should be application, and that should remain the same. Okay, so let's just clean and rebuild it one more time. Really don't know why this keeps source makefile tools extension. Also, it's not my, you know what, I'm going to disable that. That just keeps getting in my way, and for some reason, reload the window. That was really starting to annoy me, so get rid of that. All right, next, let's go ahead and make sure this all runs, and then we will solve the error that we're getting. So it looks like all of this runs. All right, so now we need to solve this. So it looks like we're getting a validation error, vk destroy device, handle blah blah blah, object type device, object type buffer. So we've got a buffer here that's not being destroyed. And then device memory, ostensibly that goes with that buffer. What buffer are we creating? Okay, destroy device. I don't think we're, maybe that isn't the UI text. Does this create a buffer of its own? I can't remember. It does. That's right, it has its own vertex buffer and index buffer. So that is why. So if we do not destroy that, which destroys those buffers, that is what gives us that. Okay, so in our debug console, when we go ahead and create this, actually I think it's going to be in the load, we create the texts, but we do not destroy them. So we have an update, the ability to get the texts, but not to destroy them. Well, that's rather short-sighted. Okay, so let's go ahead and fix that. I'm going to call this debug console unload. So we'll go ahead and UI text destroy, and that's going to be the address of state pointer. We're going to do the, let's do the text control first. And then we'll do the entry control second. And we'll say if state pointer, just to make sure that we have those things. And then we'll also say, actually, do we have a way to, determine? No, we're just going by state pointer here. So that should be sufficient. Right. So if we go here, we'll go ahead and do a unload right after that. In fact, this needs to be void because we can't really fail that, right? So that should be void. And then in the game .c, which I guess in this case, I guess we can leave the test bed as a game. Like we can just call that game.c. I suppose that's fine. We have in the initialize the debug console load, which means we should have a shutdown here somewhere. Yep. So we destroy the UI text here and unregister from the events. So I'm going to put debug console unload right there. And that actually should be all we need to fix those Vulkan errors. So let's go ahead and run. Right, and we see here, got a bunch of crap loaded. Woohoo. Let's go ahead and exit. And there we go. So that is the Vulkan error fixed as well. Okay, so for this, I'm a little bit happier with the way that we have all this laid out. Quite like that, actually. So I think right now we're actually, I'm pretty sure we're making good time. We're only half an hour in. So I'm going to actually get status. Are we on a new branch or am I still on the old one? So let's actually get checkout. We'll call this feature, actually, Factor Engine App. Right, commit. Renamed application engine and game application. Right, and I'm actually going to push this right now because this will keep the changes separate. So I'll go ahead and say push live, and we want refactor engine app. Push that. Man, what the heck is it pushing? $38 megs. What the heck is it pushing up? This should be an interesting pull request. Did it rewrite the Sponza object maybe? It's the only thing I can think of that's even near that big. I'm gonna have to double check that pull request. You think the audio is messed up. Really quiet and staticky. Oh, that's not good. Okay. Let me try changing that a little bit. Let's see. So we have the right. How is this? Is this any better if I talk like directly into the mic? Is that any better at all for the audio? It's better. Okay. I wonder, maybe it's just the position of my microphone that's kind of bad then. Let me try moving it a little closer. But not as good as usual. Huh. I wonder why. I wonder if it is Streamlabs messing with something. In fact, yeah, I can see that the levels are a little bit still kind of like muffled. Okay. Let me see. So I'm going to mute just for a second and try something. Okay, test. Testing. I don't know if that's any better. I don't see a way to boost this in here, which is kind of strange. Did the staticiness kind of go away? Try pushing the gain up a little bit. Maybe that'll help. That is interesting, though. I never had that issue with OBS, so maybe it's something having to do with OBS. Sorry, not OBS, but Streamlabs. The other two streams were fine. That is so strange. Okay. I wonder if this, maybe it's that. No, that's gonna only put it on one side. Okay, so the down mixing should be there. Let me check. Let me check my settings in OBS if I can actually do that without killing the stream. Should be interesting. Because I'm wondering. See, OBS actually allows me to fine-tune this a little bit more. Streamlabs does not seem to allow me to do that, which kind of sucks. So, I may have to Owen Codes, thank you for the follow. I appreciate it. Sorry for the technical delays, issues here. Happens to the best of us, I guess. But I'm having an issue now where I guess the audio quality isn't very good. So I'm not sure if... I'm actually going to turn myself up on the stream real quick and see if I can hear it. Does seem a little quiet. All right. Well, I mean, I don't hear staticiness though, so I'm not sure what the issues are the bane of our existence. Aren't you sure? Okay, so yeah, I guess maybe it is maybe just a microphone positioning issue. I moved my whole setup around recently, and so maybe I just didn't get the microphone put where it needs to be. Of course, now it's in front of my face, in front of the camera, so let me see if I can fix that. How is that audio-wise? Is that better? I can always reposition it later. Okay, all right. I'll just make sure that I stay closer to the microphone then. Okay, cool. All right, so where was I? So, yes, I was in the process of pushing this up. Oh, that's right. It was like 212 megabytes. Why is that so large? Let me pull up the pull request. And can't automatically merge. Okay, that's... Why not? Oh, I bet I need to... I think I know what I need to do. So... I think I'm just missing... what do you mean? Head detached at live. Oh. Is that what I need to do? No. I thought I had that right. There we go. Okay. So crap, what did I call the branch? It was refactor engine app get merge main. Yeah. Conflicts out the wazoo. 50 files changed. How was this branch so far behind? You know, every once in a while, Git just kind of sneaks up on you like this, and for some reason just cannot resolve these changes. Even though I went through all the refactoring tools and everything else, every once in a while it just kind of does this, and it's really annoying. So it looks like we have merge conflicts in basically everything we changed, which is pretty sweet. Okay, so we want the current change. And this one down here, app state. This is because that was something new, so that's engine state. So that's fixed. Oh, I get it, because I didn't pull in the changes from the other branch. Oh, that was stupid. I shouldn't have done that. Right, and all these things were wrong before. So now I'm going to have to manually merge these. That's really annoying. Okay, well. So this set is correct. This set is also correct. Yep, okay, so I can do incoming change on that one. Yeah, incoming change, that's a little cleaner. And wasn't planning on having to do a conflict resolution live, but here we are. Okay, so that's that one. This is what I just added, so that's current change. All right, that file's good. We want current change for this one. Okay, we want current change for this one. I think these are all going to be current change, but I don't want to just like blanket accept that, because that can lead to even more problems. So that's current change. Keybinds. Let's see. So we want current change on that one. Oh, this one's probably going to be littered throughout here. Yeah, okay. For this one, I'm actually going to keep all current. Looks like we missed a few things here. Event context, why is that? That might just be IntelliSense giving up. Okay, so accept current change. And yeah, we want current change on this one as well. All right, let's clean this and rebuild just as a sanity check. And I think what I'm going to do here is create a pull request, merge it, pull back down from main, and create a brand new branch, because that was super obnoxious. Okay, so I'm going to do run task post build just to make sure nothing there broke. All right, let's go ahead and run. And we'll load, test some commands. Looks like we're good, except for why state pointer is a null. What? Did we call that more than once? Why is that? Why am I getting a null pointer exception here? Read access. Well, maybe that's not what the problem is. Registered commands. No, this is a null pointer. I suppose I should be saying, be checking state pointer here. Let's try that one more time. All right, so I have this here. I think what I did was load something, try something stupid, and then exit. That must have been it. Okay. All right, so get add, get commit, and resolved merge conflicts. Annoyingly, get push. Live refactor engine app. Oh, refactory. Okay. All right. So now I should be able to pull down this merge request, and we should be able to merge. And we can. Awesome. So we should just have our initial like 21 files. Just going to do a sanity check on this real quick. So we have application types, which used to be game types. That looks good. Yep. Okay. We'll load this diff because that's important. Engine C. This is mostly just going to be renames. All right. I think we're good. Game types. Oh, wait. This was deleted. Yeah, because we have application types now. Okay. I think we are set. So let me go ahead and I'll first make it to the bottom of this. Yeah, we're good. Okay. So I'm actually just going to copy this commit message and just put it here. And I'll create the pull request. And come down here, squash and merge, get rid of all that. And confirm squash and merge. Delete the branch. And now I can go get pull live main. I really need to change the remotes too. So for an explanation on what I'm doing, where I have to type live all the time, is because my old way of managing these things is I actually have two separate repos. I have sort of a private repo that I push sort of the pending code into, and then I have a live repo, which is the one that you guys all have access to. And the reason I separated those out was because I would oftentimes record a month or more, sometimes videos at a time, and needed somewhere to actually put those commits. But since we're going to be live streaming the dev on this engine from now on, basically, we don't really need to do that anymore. So what I'm going to do instead is probably just stop using the private repo, which I had set to origin here, and I'll just start using the live one for everything going forward. And that way I don't have to manage that anymore because it's kind of confusing. But you guys won't see any of that. It's just confusing on my end. Okay, so we should be on the main branch now. We are. So I'm going to create a new branch, and I'm going to call this feature kvars. And this is where we are going to implement our Kvar system. So I kind of touched on what Kvars are before in the last stream, but basically we need a system to hold global variables for us that are configurable and settable sort of in the context of the engine console and from elsewhere. We want to be able to get those things in code as well. And so we need some sort of global way to create these variables and set their values and get their values and things of that nature in a way where the engine doesn't really have to be aware of what they are. It just kind of has a mechanism to say, hey, give me a value for a variable called this, and it'll go ahead and return that thing. And so what we're going to do is we're going to implement this in a few different phases. We're going to start off with a very simple system that for now only stores numbers. And we'll eventually expand that to store some other different simple types as well. And in fact, I think for right now, we're just going to have it store integers. Because integers can also be used to represent a Boolean, which is kind of useful and probably will be the thing that we use it most for. So for right now, we're just going to start off supporting integers only. All right, so I guess the place to create this would be, do we want, so we have our console. I guess kvars probably should live in core as well. So we'll create a new file, call that kvar.h. And the data structure for this is going to be private because we don't need the entire application to understand how kvars work internally. It shouldn't really care. All we care about is we basically want a interface where we provide the name of a kvar by string, and we should have the ability to get or set that particular variable by that. And then, of course, return a Boolean as to whether or not that was successful. So the interface I'm thinking of is probably going to be, well, first off, we're going to need to do, we'll call this B8 kvar initialize, and we're going to take a U64 pointer memory requirement, right? This is another kind of system on its own. So we'll have memory requirement, and then for now we'll just take a void pointer to memory, right? And this will follow the same pattern that we've done elsewhere in the system, where the first time we call it, we're going to pass void to memory and just get the memory requirement. Then we can go ahead and allocate some memory for it, and then go ahead and call it a second time, passing memory through. So we'll go ahead and do that. We'll also have a void kvar shut down. And this is just going to take void pointer state, just like every other system we have. Now, one thing I'd like to point out is if I go back to engine C and we go to our initialize, oops, I thought it was here. So actually it's the shutdown I want. I don't want the initialize. Shutdown. So all of our shutdown calls take the state object itself, or the state memory itself. And in most cases, we're not actually doing anything with that because we have this sort of statically allocated state pointer. And one of the things that we're going to be doing when we come up with the systems manager is we're going to be doing away with a lot of that static stuff. And we're going to be just using these pointers that are passed through for a lot of things. But we're going to have to do it in such a way where we don't have to have that state pointer everywhere in order to be able to use it. So I've got some ideas on how I'm going to do that, but I just figured I would give you guys a heads up on that stuff coming. So that is our initialize, and then we're also going to need B8, Kvar, create, and we're going to call this create int, right? Because we are going to be supporting multiple types of variables. And so I'm going to start off creating ints. And I'm not going to worry about the various sizes of ints. I think I'm just going to have an int32 be supported. I'm not going to worry about unsigned types. I'm not going to worry about the various sizes or any of that. I think it's just going to be int32s or i32s, and that's what we're going to roll with. So to create this, we need a const character array. We'll call that name, and then we will also need, I guess it's just going to be i32 value. I can't think of anything else we'll need for that. Likewise, we'll have a kvar get int, for lack of a better term. I'm not 100% sure I like the name get, but we'll have a constant character array called name once again. And this time we will have a i32 pointer out value. And you'll notice here I'm returning a Boolean. That is because the the puzzle maker. Thank you for following. I appreciate that. Thank you for the support on that. I really appreciate that. So we're returning a Boolean here because we want to indicate whether or not we actually found this integer. So that is why we're not just returning the int directly. So instead, we'll have to return that using a pointer. That should be all we need. And of course, when we go to create kvars for like a float or maybe a string at some point, I'm not sure I want to support that yet. Then we'll be able to just add functions here to that. All right, so we have that. We need our C file, so kvar.c. First thing we need to do is obviously include kvar.h. I know for a fact we're going to need core k memory. So let's go ahead and paste this in here. One more thing before I forget, the h file, we need to expose the create and the get. Oh, you know what? We also need a set because this sets it on creation, but if we want to update that, we need a way to do that as well. So we need a set as well. So I'll go ahead and paste that in here. All right, so for initialize, we are going to need, obviously, a structure to hold our state, right? And for now, I'm just going to keep this super simple. So let's do, actually, type def struct kvar state, kvar system state, right? And we'll also type def struct kvar int entry, right? And this is going to represent an individual int variable. So that's going to have a const. Do we want a const? Yeah, we'll just string duplicate it. Heck with it. So we want a const character pointer, or array rather, name. And then we want a i32 value, right? So it's kind of like a key value pair. It's basically what we're looking at here. And so our state is going to hold a whole bunch of these. So we'll call this ints. Ints? Yeah, ints. I don't really like that name, but for now I'm gonna roll with it. Okay, and of course we have that, so we need a static kvar system state pointer, right? And so our initialize is going to be dereference memory requirements, and we're going to set that equal to the size of kvar system state, right? And that's going to be our memory requirement right now. So we'll say here if not memory, return true, right? Because if we do not pass memory there, we are just basically saying what's the memory requirement here. If we do have memory, then we'll set the state pointer equals to memory, and we'll also need to go through, and I think we can actually just zero out. Actually, depending on where that comes from, that might not be zeroed. So let's go ahead and play it safe. So k0 memory, state pointer, and then size of kvar system state, right? Then I'll just zero out the entire block. We'll be safer off that way. Hey there, also known as Paradoxal on Discord. Hey, how is it going? Hopefully everything is going well for you tonight. Welcome, welcome. Okay, so we've zeroed that out. I think we can just return true for now. We don't really need to do anything about that. All right, so for the shutdown, if state pointer, again, we're not using this right now, but we will be in the near future. So if we have the state pointer, in fact, you know what? We actually do not need to do anything, but just to make sure that we have nothing sort of sticking out, let's go ahead and, wait a minute, what am I doing? That's why. That's missing a pointer. I was wondering why I was getting errors all over the place. Okay. So all we're going to do in this case is just zero out the memory, which will clear out this whole guy here. So I'm maxing this out at 200. We could change this, make it configurable, do a lot of things with it. For now, I'm just looking to get something up and running, so I'm just going to kind of hard code that to 200. I will put some sanity checks in here to check for that. In fact, static const, actually no, because that's going to be, let me do it as a define. Kvar int max count 200. Let's not use magic numbers, right? All right, so that's that. So I think the next thing we'll do is we'll go ahead and talk about creating an int. So basically what we're going to do is, first off, we're going to check that state pointer exists, right? If it does not, we're going to, in fact, you know what, let me not do it this way. If it does not exist, we're just going to boot out right away, right? We'll say if not state pointer or not name, right? Because we need both of those things. And now we can say we'll need to loop through and find basically a free element in this array. And we can find the free element by just looking for whatever name is a null pointer, right? Because when we zero out all of this memory, these two things will also be zero. So we could just check to see if this is a null pointer. So we can say for, u32 I equals 0, I is less than kvar int max count plus plus I if actually, you know what? Let's grab a pointer to this guy. So state pointer int I. We want the address of that, and that is going to be a kvar int entry, right? So we'll just obtain a pointer to that guy for convenience. And then we'll say if entry name, if not entry name, meaning it's blank, then we'll go ahead and break here. But before that, we will, in fact, we should return true here and return false here. And the reason for that is we need to include core logger. If we get to this point, that means we've iterated through all of these and not found an empty slot. So we actually have to say kerror, kvar. Let's actually just do this. Kvar create int could not find a free slot to store entry in, right? Be explicit about that. All right, so if we don't have an entry name, we're actually going to need string as well. Include core k-string. So we can say entry name equals string duplicate, right? And we'll pass name to that. So we'll automatically have that. And then entry value is going to be value, right? And that is all that goes into creating a new integer value, right? That's it. So pretty straightforward stuff there. All right, so for the next thing, we're going to go ahead and take a look at getting. So the first thing we're going to do is just copy this sanity check here. I'm also going to copy this loop. Actually, I'm going to copy all this code because a lot of it's going to be very, very similar. So we're going to do a loop like we did before. We'll change this error message here because if, we will say could not find a kvar named, and then we will append a string here, name, right? So in this case, if we have an entry name, then we also need to compare, so string equal, and we could either do case sensitive or case insensitive. And I'm thinking case insensitive, just to make it a little bit easier to use. So I'm going to say if strings equal I, name and entry name. And we probably ought to be using the n variant of this, but for now I'm going to leave it as is. Why is this bleating? Oh, okay. It's IntelliSense freaking out. Okay, so if they match, then all we have to do is we have to dereference out value and set that to entry value, right? So we just literally copy it over, and that's it. We can return true, and then we have our int. If we're going to set it, the code for that is remarkably similar once again. So we may wind up doing something like maybe generalizing this somewhat, but for now, it's just enough different that I'm not really worried about it. So in this case, we need to still search by name. The only difference here is, whoops. So our function here is actually wrong. This should be just a value, not a pointer to that. And this also needs to include defines. Yeah, so this should be just an I32, not a pointer. And then we just say entry value equals value. And that should be it. Change this error message, and there we are. So that is basically the start of our Kvar system. One more thing that we're going to need is we actually need to include our core console, right? Because we need to integrate this with our console so that we can actually have some commands to be able to use these various functions within the actual console itself. So that is what we're going to build in next. And I'm probably just going to let's see. So I think I'm going to how do I want to do this? So we're going to have to register some commands. So I guess this is going to be the first thing I'm going to need is the signature for that. So let's go. Let's create a new. We'll call this B8 register console commands. Right. Actually, do I need that to be? That could just be void. Okay, so what we're going to do is we're going to have our individual commands that we're going to register here, and then we'll go ahead and register them down here. So I'm going to call this first one let's do the create and then the get and then the set. So Kvar console command create. I'm not sure I like that naming scheme, but that'll have to work for now. So what this is going to expect is that we have, in order to create I'm going to have to say create int, I guess. In order to create an int, we're going to need two arguments. We're going to need a name and a value. So the first argument we're going to process as a name, and the second argument we're going to process as the value. So I suppose we could first say context argument count is not equal to 2. Requires a context arg count of 2. Now, technically speaking, this should also be handled by the console itself. So actually, we probably really don't need to do this, but just to be explicit, I'm doing it anyways. And so what I'll do is let's do context arguments 0. And I believe that is just value. which is a constant character array. So we'll say const character array name equals that. And then we'll say val string is the second one. Okay, so we'll go ahead and get the value from that. String to I32. We'll go ahead and use that. Whoops. And we're going to go ahead and pass the val string here. And then we need an I32 to write to, so we need I32 value. We'll just default that to 0. And we'll pass the address of value. And then we'll say if, for some reason, that fails, then k error failed to convert argument 1 to I32. And we'll print that as a string. This way we have the most information available to us as possible. So we'll say val string and return, right? So we're not going to register in that case. So basically what we're going to wind up with is the name, the value string. We're going to try and convert that to an I32. If all of that is successful, then we can say kvar create int, and we'll pass along name and value. And we can actually, we'll check that too. And if that fails, k error failed to create int kvar. And there should be some explanation as to why that is by this point. All right, so I think we've got all of our bases covered here. Yeah, that looks correct. And so now we can actually say console register command, and we'll call the command, what do we want to do? I guess we would call it kvar create, int. And this is going to have an argument count of 2. It's going to be using this function here. All right, and this is basically going to be the pattern for us to implement various things of various functionalities into the console. So let me go ahead and prototype this at the top here. I'll do it here. Right, and I will tie this into our initialization as well. Right, so that we automatically initialize our kvars. So we'll just need to make sure that this happens after the console is initialized, which shouldn't be too big of a deal. Okay, so that is the create int. I'm going to go ahead and copy this and create another one, except this is going to be, how do we want to do this? So in terms of the console command itself, get doesn't really make any sense because the console doesn't really have anything to do with the value that's gotten. So I'm going to call this print int, and this is going to require one argument. And basically all this is going to do is print the kvar to the console if it finds it. So I'm fairly sure I'm going to be able to remove these checks, actually. I think those are actually done by the console itself. But okay, so we have we only have one argument here, so we don't need to do any of this name processing. We don't need to do any of this. We do need the value, so we need to say kvar get int. We need to pass it the name, and then we need to pass it the address of value, right? And then we'll just do a quick check on this to say if that fails, Actually, can I just copy this? Oops, just return. Failed to find Kvar called S, and then instead of value string, we'll do name. Yeah, that should work. Okay. Otherwise, we will have gotten it. So what we can do then is console write line, log level info is what we'll go with there. And we'll say string do we actually have a I don't think we have anything to convert from a number to a string without having to do a string format, which kind of sucks. But we don't know how long that's going to be, so actually let's do a character pointer. Call this val string, and we'll say string format. And whoops, yeah, that's not the interface for that at all. Shoot, how do we want to do this? Because this is going to require destination buffer. You know what? We're never going to have like a number that's beyond like 30 digits, I don't think. So let's just do character val string. I don't know, let's do 50, right? And then we'll just say equals 0. Right, we'll just zero that out, and then we'll do a string format, val string. The format is going to be an I for an integer, and then the integer itself, which is going to be value. Right? I suppose we could do some checking on that. Oops, looks like we have an extra character here. All right, so I guess we could do some checking on that, but I'm not going to bother for right now. And then we could just write out val string. And that's it. So we should just be able to do that. So I'm just going to copy this, and instead of create, print, takes one argument, and plug that in. All right, and so finally the last one is to be able to set it. So let's go ahead and I'm actually going to take a copy of this one because it's most like what we're going to need. So instead of create, we're going to say set. Right. Requires constant count of 2. Name and value string. Here we go. So name and value. We're going to go with the same thing on that. We still have to parse the I32, so that is good. We still need that. The only thing we're going to do here is change this to set int. And that should be fine because called, we want to be explicit about this. If it doesn't exist, we don't want to try setting it, right? So name, okay. But that should be all that is needed for that. I suppose we could actually output some info here. So maybe we put this? I guess we could just do the same thing as what we did right here. Just a simple string format. This time we'll leave a lot more room, right, in case we have a long variable name or something stupid. We'll do S for the variable name. We'll say equals and then I, right? So we'll just write that out just as is. So we'll say name and value. Yeah, that should be it. And then value string gets written out. And there we have it. So that should be all we need to set that up. All right, so we'll just register that as well. We'll say set int. And we'll say set int here. All right. So I think we're looking good so far. The last thing, oh, you know what? That needs to be 2 because that needs 2 arguments. The last thing I think I want to do is go through and actually have something to print all of the Kvars that we actually have in the system from top to bottom, because that might be useful for us to actually wind up doing. So I think I'm going to go ahead and do that. And that actually requires no arguments. So I don't know, I guess I'll just copy this top one and change it as needed. So I'll say print all. Okay. We're not even going to check that because we're not going to use arguments. We don't need that. But what we will do is grab our loop from up here. And see, for each one of these, we are going to basically do a string format. And again, I'm going to use something stupidly large. And in this case, we're going to say, in fact, didn't I just define this right here? Let me do this. Okay. Get rid of that. Whoops, actually don't get rid of that. We need to have an entry name. Say if not entry name. Oops. Continue. Actually, I guess it's kind of cleaner to just do this. Right? Okay, so entry name, entry value. Okay? And we'll put a note here. Int vars, kvars. Right? So, other variable types, right? So for each one of these, we also want to move this guy up here. For each one of these, we're basically going to print the name of the variable and then its value, if we have that. And that should actually be all that requires. So we'll just register it, print all. This takes 0 arguments, and we'll say print all. And I think we've already hooked this up. So we should be in a good position to go ahead and build. What did I miss? Couple things. Discards qualifiers. Well, why isn't that constant, actually? That should be constant because this should never actually be written to. So that's actually a bug. Okay. Let's see. So let's go ahead and update the interface for that, because that's kind of stupid. Ugh, there's a lot of them too. Yeah, I'm just gonna update the ones we need to update right now. So all these, change them to constant. I don't know why I didn't have them constant to begin with. It's kind of dumb. Wait, string split. Yeah, that already was constant. Okay. So let me see. What did I not change up here? String mid. String index of. Yeah, that should probably be const as well. Okay. So from here down, basically need to swap all these to const as well. Hate finding stuff like that, but it is what it is. Do any of you guys have any questions while I'm doing this, by the way? If you do, feel free to speak up. I think that's all of them. See how many of them I missed. All right, so redefinition. Oh, because I have that up here. Let's call this out string then. Build. Okay. All right, let's go ahead and run this and see what we get. So theoretically, we have our list of commands down here. Can I move this over a little bit so we can actually kind of read it a little bit? No, not really. That's fine. All right, so in here, I can say Kvar. Ooh, underscore doesn't work. Okay, that's not going to work. Hold on. So apparently underscores don't type in the console. Anticlimactic. Let's see. Oh, right, because I didn't include those keys. All right, where was that? Was that here? I thought it was in debug console. Debug console, not console. Where is it? Debug console on key. Here we go. All right. So yeah, case key. Is it minus? I think. Minus key. Care code equals. And this is if shift is held, so we want that. Break. Oh, you know what? This actually needs to come down here. So we'll say if shift held, then we do this. You know what? That's kind of dumb. Let's make this a little bit character code equals shift held. Let's use the ternary here. Right? Ah. Okay. Why is that? My formatter is going bananas here. All right. And then case key equals, I think is what I call it. All right, I'll just snip that in there. And for the equals key, if shift held, we're going to get a plus. If it's not, we're going to get a equals. We need to greatly expand this, but I think that should work. So let's go ahead and test this out. Failed to pop key map. What is going on here? Okay, we've got some sort of key map bug, but... All right, so those work at least. Why is the key map? All right, you know what? Let me relaunch real quick. I'm not sure what happened. Oh, interesting. The key map is not popping for some reason. Stack pop. Oh, that's interesting. Okay, I'm not sure what caused that, but all right. I don't remember that being a problem before. Oops, not change all occurrences. Find all references. State pointer. So if stack pop, why would this be failing? It's getting this. I'm going to put a breakpoint here. And I'm going to open the console, close the console. Or that should be not output element data. Wow. Fail. All right, I'll bet that. Yeah, now it works. Okay. All right. So let us test our commands. So what did we call them again? I'm not familiar with them because this is my first time using them, so I don't have the names of them memorized. Wow, we have way too many files open here. Let's close some of this. We really don't need. We don't need a good portion of this, actually. Geez. Why is all this stuff open? That's kind of ridiculous. No wonder IntelliSense can't keep up. All right, so that is done. What do we have here? Debug console. All right. That should be a little bit more easy to manage. Okay, so back to what we were doing. Let me just load some stuff up here so we actually have kind of a sane background. One of the things we really need to address is drawing something behind this text so it's a little bit easier to read, but for now, we're just going to test this out. So I will say kvar create int. Should probably get rid of those as well. And then space. The name is going to be, I don't know, let's call it test A. And then we will set its initial value to a good number, like 69, and hit enter. Kvar create int does not exist. Okay, so it definitely should exist. Is this not getting called? It's definitely not, because here's the engine running. So, oh, you dummy. I didn't actually hook up Kvars into the engine. What a dingus. Alright, so let's do... Yeah, I'll do it here. Core kvar.h. Actually, this kind of belongs with systems, though, to be honest. I may wind up moving this and creating a system out of it. Let's put this immediately after the console, because that's the way that it's going to get initialized. So console memory requirements, we're going to do a copy of this for Kvar memory requirement. All right. And then we will Kvar initialize. We want the engine state, Kvar memory requirement, and 0. And then we're going to have a copy of that, but we're also going to say engine state Kvar state. All right, so we can get rid of these things. And then we need this guy, a copy of that guy anyways. And Kvar state. Systems allocator, that's correct. Kvar memory requirement. Okay. Kvars. Let's build that. And I'm pretty confident that this is actually going to execute this now. So let's go down here and get rid of this breakpoint. Did I build already? I think I did. Okay. Run this. All right. And we'll go ahead and load again just so we have some decent stuff to look at here. And move this out of the way. So we're going to say Kvar create int. We'll call this test A, and we'll set it to a value of 69. And now that we see this output here, we don't actually have confirmation that that worked, other than the fact that we didn't get an error. So I guess we could say Kvar print all. Whoops, all. And we got some rubbish here. Not supporting 5 and 6 byte characters, invalid UTF-8. Okay. So what do we have? What do we have? Go ahead and troubleshoot this. Is it maybe this it doesn't like? That's the set int print all. So let's go ahead and do Kvar print all. And see, that's very interesting, because it didn't even execute this code. K-string bytes to code point. So it's failing even before. Where is that actually? That's interesting. So I'm going to basically do this again. Kvar, oops. Really? Okay. So is this the shift pressed? I wonder if it's like finding the shift press. I can't imagine that would be the case, but I wonder if it's somewhere in this logic where that's actually happening. So if I just press shift and I don't type anything, it's fine. Kvar print all. How is that? And why am I getting 3? Yeah, see, and now it's messed up because it's trying to print some sort of character in here that we don't understand. What is it doing? So I guess if we get this error, let's go ahead and break on that. Right, and then I'll come here, kvar print all. Where are we actually getting this error from? Verify code size. Text. So here's the text. Which, who knows what the heck is in. All right, let's say text. Why is it just picking 91 as like the first? Oh, I guess that's character 91. And we're at 374. Oh, that is indeed rubbish. So I guess let's check out the set text. As it seems to me, three 374. Print all. It's not terminating correctly. So when I hit enter here, it's not terminating the command. Does that even happen with? And it's just choking on every character after that. So let me see if that happens if I just open the application and hit exit. Let me see if that happens. So if I just do this, no, it's not. Interesting indeed. It's probably something goofy I'm doing in here. So we get the length. Entry control next. And this is probably actually what's causing it. Well, no, it's not actually. What would be... Not supporting. Why would that be? Buffer position is 377. Oh. Let's see, how are we doing on time here? We're at about 2 hours. So actually, I think it's actually 11, which is technically when I really wanted to end the stream. So I think at this point, I'm probably going to just pick this up next time. Because I have a feeling we're just terminating on in the wrong position here. Because our buffer position is 377, and that's obviously wrong. So something that we're doing in here is wrong. And what we'll do is next time we will troubleshoot that. Because like I said, I'm actually out of time, and I have to work tomorrow. So yeah, with that, I'm going to go ahead and wrap up the stream here today. We do have the feature implemented. It looks like we've just got a couple bugs that we have to sort out. So I am not going to check in what I have, or actually I'll go ahead and create a feature branch and push it up, but I'm not going to go ahead and put that into the live main branch. So what's our branch here? So yeah, I'll go ahead and add this commits. Kvars implemented. Crashing on console command. Actually, yeah. I'll just say work in progress 1. Feature. Oh wait. Live feature. Kvar. Kvars? Was it Kvars? Kvars. All right. And like I said, I won't do a pull request just yet until I actually sort out this issue. And then what I'll do is I'll just get this issue sorted out and in the next stream, and we'll go ahead and implement the next feature in the next stream as well. So we made it most of the way today. Not quite a total success, but that is the reality of when we live stream stuff like this. Sometimes you just aren't able to finish the feature within the time slot that you have. So anyways, I want to thank you guys so much for watching and sticking with me in the stream here. I feel like we've made some pretty good progress today. But anyways, if you could go ahead and follow if you haven't already, I would greatly appreciate it. Those follows help me out a lot. And if you guys haven't seen my series over on YouTube, I highly recommend you check that out. You can just go to youtube.com/Travis Roman, and you will find the rest of this series there. With that, I'm going to end the stream here. Thank you guys so much for watching. I'll see you guys next time.